A pleasant good afternoon or good evening to everyone. I am Jem B. Castillo. I was the Deputy Project Leader of the Nature-Based Solutions for Flood Risk Management in Philippine River Basins project of the ADB. I'm presenting on behalf of Deltares, a firm based in the Netherlands, and Resources, Environment and Economic Center for Studies, to which I belong. This presentation is part of the complete report on NBS for 3 of the 6 river basins of which master plans have been prepared with funding from the Asian Development Bank. NBS applications differ in each river basin, indicating that the design of suitable NBS highly depend on site-specific factors. This project was also part of the regional project entitled Protecting and Investing in Natural Capital in Asia and the Pacific, and as input to the Philippine Infrastructure Preparation and Innovation Facility, or IPIF-2, of the ADB. Let me begin by describing what NBS is in the context of river basins. NBS, as defined in this project, are actions to protect, sustainably manage, and restore natural or modified ecosystems that address societal challenges effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. These actions can be a mix, such as removing obstacles, zoning, retreat of embankments, floodplain and wetland restoration, land use management, etc., the application of which depend on the conditions at the site. Let me now provide you with how NBS is implemented. First of all, the ADB provided a few guidelines in mainstreaming NBS in the water sector. Here I present 4 guidelines. First guideline is aimed to define the best set of interventions for long-term sustainable river management. Second, facilitate a well-informed dialogue about NBS in river basins. Third, consider upstream and downstream risks and impacts measures. And last, reflect the co-benefits of measures. In setting up NBS, we recommend the following steps. Step 1, definition of goals and objectives. Step 2, system analysis. Step 3, selection of hotspot areas. Step 4, selection of NBS. Step 5, impact and economic analysis. And step 6, prioritization of interventions. And step 7, implementation and, of course, maintenance and monitoring. Identifying an NBS goes through a stepwise process. Let me just show up and briefly explain some items. The flow chart gives some guidance on the selection of feasible NBS to address the identified flood risk management problem at the site within a river basin. This flowchart includes only NBS that address flood risk management. There could be several other options outside of what is included here. So it is a stepwise process starting with what is considered hotspot area. The NBS in the green boxes are for upstream of the hotspot. The brown NBS downstream are the salmon NBS at the hotspot area. The NBS in the orange boxes are an exception. A hotspot with substantial erosion problems will benefit from bank retreat and zoning in the hotspot, whereas flood reduction, it would be more efficient to implement these solutions upstream of the hotspot. Availability of sufficient space, presence of people, and presence of a floodplain are some of the main preconditions to be able to take the NBS. Here is another illustration of what I have briefly pointed in a previous slide. So beginning with the hotspot, the selected hotspot areas face the largest problem in the basin. Hence, solving these problems have a high priority. Instead of outright interventions in the hotspot area, it is recommended to first assess all possibilities to retard flood peaks and store floodwaters upstream of the hotspot area. This is number 1. Examples of options as shown in the upper list includes restoration of natural landscape, land use management, wetland restoration, etc. If there are limitations in implementing NBS upstream, explore possibilities and further downstream of the hotspot. That is number 2. Examples of options are removal of obstacles, relocation of people, zoning, or building embankments. I will now describe the identified problem in Tagum-Libuganon River Basin as described in the master plan. In Tagum-Libuganon River Basin, problems in the upstream are the dam tributaries are causing frequent floods. Midstream, high slopes makes these areas susceptible to landslides. The municipality of Asuncion and Corella are hotspots for flooding. However, the Saog River provides for irrigation of banana plantations and for recreation. At the downstream, large parts of the rivers are embanked and straightened, thus disconnecting natural tributaries and cuts off drainage from the plain. Roads are acting as dikes, and Libuganon's estuary has been disconnected. Rivers are overflowing. The key hotspot identified for application of the NBS identification process is the municipality of Carmen, specifically the flooding that occurs in Tuganay, Alihal, and Ising. The key issues here are waterlogging due to lack of drainage, river flooding and flooding because of typhoons, human-induced issues including mining and quarrying activities, and lack of solid waste management. The map on the right of the slide shows that Tuganay River overflow into the Ising area. A review of the map in Google Earth indicates that its elevation is lower than areas further downstream. This area is experiencing constant flooding that overflow into the residential area. Those red patches in the lower middle. We propose an integrated approach that explores the following measures: construction of bridges and culverts in the road, reviving of the Ising River, comprehensive land use planning, retention areas in combination with wetland revival, and Green River between the Tuganay and Ising River. So the focus of NBS is on reviving the Ising wetland to enhance drainage capacity. The map shows active agriculture areas within the wetland, part of which has been assessed by the Biodiversity Management Bureau and is considered a potential local wetland. At the upstream of this proposed wetland retention, we propose evaluation of the current land use practices by exploring appropriate ratio between rise and wetland to optimize flood risk reduction and agricultural productivity. Next, we assess the co-benefits of the proposal. Based on our assessment, reviving the Ising wetland, apart from direct benefits to flood risk reduction, reviving the Ising wetland have the following co-benefits: water purification, provision of vegetation filters to trap water contaminants that could improve water quality, water retention and flood risk reduction, storing and slowing down of floodwaters that could protect downstream areas from destructive floods, sediment trapping to reduce soil erosion, serving as habitat for important flora and fauna, which could serve as food for locals and source of wildlife, to support ecotourism such as bird watching, recreational fishing, and biodiversity value. Next, we take Abra River Basin. For Abra River Basin, let me first describe the main problems in the upstream and downstream, and in the next slide in the midsection or midstream. In the upstream, the main problems are the steep slopes and loss of vegetation cause frequent occurrence of floods and landslides during the rainy season. In the downstream, densely populated communities such as those in Vigan City are prone to flooding due to flat topography. Flooding is worsened by high tidal levels. Erosion along riverbanks is common, and constructed revetments structure cut off streams that discharge to the sea. In the midsection, overbank flooding affects more than 7,000 inhabitants and more than 5,000 hectares of agricultural lands. So of the three municipalities that include Tayum and Bidigan and Bangged is a hotspot for flooding, affecting residents and agricultural lands. Riverbank erosion is also a serious problem because of significant lateral displacement and constantly evolving river channels. Communities that have settled in braided channels are extremely vulnerable to erosion and flooding. Agricultural land and vital bridges on floodplain at the confluence of the Tineg and Abra River are vulnerable to wandering channels and scouring bed incision. Quarrying is common that artificially changes the geomorphology of the basin. The pictures on the right show examples of impacts on riverbanks with adjacent agricultural areas. Following the protocols of NBS, we start with the identification of the hotspot area or areas. We have identified two key hotspots for possible exploration of NBS. In the midsection of the basin, as pointed out in the last slide, several communities and agricultural lands are exposed to flooding and erosion. These occur in the municipalities of Tayum, Bangged, and Bidigan. You will find in the picture on the right agricultural land between river channels. These are all under threat from flooding and erosion. Let me now quickly present to you some NBS proposed for each section of the basin. In the upstream, the focus is on reduction of vulnerability of communities to hazards. Proposed measures are landslide reduction through reforestation and terracing. 2. Relocation or lifting of houses. And 3. Create natural retention areas to flatten discharge peaks in the mid and lower sections. In the mid-section, the focus is on providing room for the river to accommodate natural meandering of the river. The specific measures are 1. Removing or setting back of obstacles such as dikes and levees. 2. Implementing building codes and resettlement of vulnerable communities. 3. Create natural retention areas to slow down river flow. And last, smart quarrying practices in strategic areas to divert river channels away from vulnerable assets. Now, for the downstream, the focus is on allowing for natural movement of the river mouth. The specific measures are, number 1, removing of setting back obstacles such as constructed revetments. 2. Connect old streams to reduce flood hazards in settlements along the river. And 3. Implement building codes, zoning, and resettlement to reduce vulnerability of assets. In general, the selection of suitable NBS highly depend on context-specific factors such as type of flooding, inhabitants, and natural state of the river. The natural river management approach was used in this work to assess flood and erosion problems. Room for the river was taken as a strategy. A risk-based approach was advocated. The Abra River Basin has potential to be the first basin implementing the smart adaptive quarrying strategy, implying that quarrying will be used to reduce riverbank erosion and flooding instead of constructing gray infrastructures. Let me just introduce briefly a multi-criteria analysis approach to compare strategies identified in the River Basin master plans with an introduction of NBS. This is an illustrative example of multi-criteria analysis in Buayan, Malungon River Basin. With limited time to explain, I'll summarize that with the multiple stakeholder analysis, a multi-criteria analysis can be used to compare combination of strategies that includes NBS. In this analysis, two master plan strategies do not differ significantly. This, however, will be subjected to further stakeholder consultation. With just a few seconds left, this is a summary of the proposed NBS intervention in the 6 river basins. A final note, all these recommendations were based on experts' analysis but will be subjected to consultation with the stakeholders at the sites. COVID pandemic happened, hence the consultation was put on hold. Thank you for listening, and I am happy to entertain questions.